Hello, my name is Michiko Ueno. Thank you for your interest in our research on the continuous and gradual style changes of graphic designs with generative model. It is performed jointly with Shinichi Sato at National Institute of Informatics. Our paper contributes a novel interaction method for exploring the graphic designs with parametrical manner. It is difficult for novices to create high-quality graphic designs because they have not accumulated any ideas about the layout. The retrieval and refinement techniques for graphic design are not useful to a user who have not accumulated about it. Therefore, the support and suggestion technique that give alternative ideas are important for such users. However, that techniques in previous works are presented with discrete representation, such as thumbnail view. These interfaces are not adequate for accumulating different layout samples or mapping relationships between layouts. Thus, we focus on the techniques to present layout design with the view that continuously change the layouts. There are some previous works for creating graphic designs. We categorize previous works into two categories. One category is layout design support. Previous works included in this category are focused on the interface to support user creation of layout design. Designscape and Sketchpro are interfaces to improve the layout created by the user with optimization methods. Designscape also suggests alternative ideas of the layout designs. However, these proposed optimization methods are unable to generate complex and flexible layouts such as those created by skilled designers. Moreover, these works presented such layout ideas with a discrete thumbnail view. This presentation method is not suitable for exploring a large number of layout designs. Thus, we use a neural network model in this study to generate complex layout designs and continuous layout changes. The other category is layout synthesis by deep generative model. Previous works included in this category are focused on the automatic generation of the layout designs with a deep generative model. Layout GAN is a parameter-based deep generative model which generates various types of layouts such as document and clip art. The content-aware generative model generates graphic designs based on the content such as images and keywords. These models are helpful, but they cannot be adapted directly to continuous graphic design changes. Our proposed method is a pixel-based generative model to generate layout segmentation images. Our model changes graphic designs between two graphic design styles continuously and gradually. To achieve this method, we introduce a novel encoder-decoder-based deep generative model comprising dual adversarial constraints. The animations on the right side are the results of our proposed model. The left animation is the result of the refinement segmentations of generated layout segmentation. On the right is the result of the graphic design rendering. These results are automatically filled with graphic elements based on the left refinement segmentation images. Then, we present the proposed network architecture. Unlike the representations of natural images, the layout designs are discrete representations. The regions of the elements are clearly divided. Therefore, we introduce some techniques in latent vectors and critic networks. First, we introduce three types of latent vectors fed into the generator. Reconstruct variables are used to improve the reconstruction results, as used in many cases of the encoder-decoder model. Interpolated latent variables are used to improve the results of the graphic design generation with the interpolation techniques. We also latent variables sampled from prior distribution to improve the results with arbitrary latent vectors. Finally, we introduce two types of critic networks. One is the encoder constraint. Using this constraint, the encoder is trained to map the latent space to the Gaussian distribution by minimizing the Kullback-Leibler divergence between prior distribution and encoding distribution. The other constraint regularizes the decoder by minimizing the Wasserstein distance between data distribution and model distribution. This constraint improves the quality of the generated results with an arbitrarily rated vector. We conducted some experiments to evaluate our model. We used the public dataset to validate our proposed method. The dataset consists of various layered semantic segmentation XML files. Those data are categorized into 6 graphic design styles, such as fashion and food. We used 3,904 images generated with those files. These images are composed of 6 types of graphic semantic segmentations, such as text and image. Then, we encoded these graphic element types in the images into one-hot vectors and used them as input. We first conducted the experiment to evaluate reconstruction. We adopted the Wasserstein autoencoder as the baseline to validate our techniques for the generation of graphic designs. We set the dimensions of latent spaces to 128. On the left side of the image are the results of reconstruction by the test set. Or the sharper and better defined boundaries of edges than one by baseline. On the right side are generated samples with random latent variables. Our proposed model outperforms the FID score compared to the baseline. Then, we evaluated the continuous and gradual style changes of graphic designs. First, we filled the graphic elements with the images and texts based on the generated layered segmentation images. To detect the regions of generated segmentations and create polygons for refinement of the region clearly, we applied some computer vision techniques such as contour detection. Then, we got the complete graphic designs. We conducted an experiment for a novel interaction method that changed the graphic design styles parametrically, called style morphing. We adopted the linear interpolation techniques to generate layers between 2 graphic designs. We could acquire alternative layered designs by changing the coefficient alpha. Some of the designs generated by the method were not present in the dataset. We evaluated the results of the style morphing by a preliminary user study. We conducted a user study to evaluate our model by 47 cloud workers. They were asked about the richness of the variations and visual appeal of generated graphic designs. We created 16 combinations of the start and end points of graphic designs. We extracted the generated 3 sample images from these combinations. We asked workers whether they preferred a combination of A and B for the richness of variations and visual appeal. The images are examples of the user study presented to workers. 72% of all responses rated the results from our proposed method as having more layered variation than baseline. And 74% rated the results of our proposed method as having a better visual appeal than baseline. We propose a novel interaction method to explore alternative ideas of graphic designs. Our proposed encoder-decoder model encourages to generate clear layered segmentations by comprising dual adversarial constraints. The model enables continuous and gradual style changes of graphic designs with parametrical manner. Some experiments demonstrate that our models generate sharper and clear boundaries of segmentation images. Preliminary user study demonstrated that our model have rich variations and visual appeal. I'd like to thank you all for your interest.